So today we have this balanced binary tree problem, and in this we have to determine that if it is height balanced or not. A height balanced binary tree is defined as uh, the difference at each node. Uh, a binary tree in which the left and right subtree of every node differs in height by no more than one, which means if you are standing on any node, then your left subtree, height of your left subtree and height of your right subtree should not differ by more than one, which means this you are standing on this, your height of right subtree is 1 because there is one node. Your height of left subtree is 3 because there are three nodes. So 3 left is 3, right is 1, 3 minus 1 is 2, which is greater than 1. So it is definitely not a not a height balanced binary tree. And what is height? Height is the maximum depth at any side. For example, in this, if you'll calculate height, uh, considering node, so first node, second node, third node, this can be height, or first node, second node, third node, this can also be the height, but first node, second node, this cannot be the height. So the longest path from your current node is height basically. Now, what will be our approach? Our approach will be simple. These two are the cases we have. Our approach will be very simple. What we'll be doing? We'll consider this right tree. Okay, this is a right tree. I'll just delete this. Give me a moment. Nice. So I'm getting used to it because it's a newer version. I'll just delete this. I guess, yep, this will work fine for me. Yeah. So my approach, what will be my approach? I'm standing on this. I'm standing on this. Okay. I want to check that if my left, why is it so thick? Like no one. Uh, what do you mean by check your internet connection? This new whiteboard is definitely buggy. Give me a moment. Give me a moment. Yep. What I need to check. I'm standing on this. I'm standing on this node. 3. What I need to check that what is the height of my left. My left height is 1. What is the height of my right? My right height is 2 because I'll just increase this by 1 because one node and two node, or you can go one node or two node, any one of them you can take. So right height is 2, left height is 1. What will be the difference? The difference will be 2 minus 1, which is equals to 1. 1 is not greater than 1, which means this is true. This is true. This is height balanced. And we need to check this condition at every node, not for only root node, for this also, for this also, for this also. So we need to check this for every node. So for example, you're standing on 20. Okay, for 20, what I'll check? I'll check the height of my left subtree and height of my right subtree. Height of my left subtree is 1. Height of my right subtree is 1. If you'll subtract them, it will be equals to 0, which is definitely not greater than 1. So again, this is also true. This is also true. I'll just mark. For this, acha, this one is circular. Nice. For this holds true. For this and this also holds true. These are true. Okay. And for this, if you'll consider what's it left, right, nothing. This is null, this is null. I need to change this. This is null, this is null. So null minus null is obviously true. Null minus null is nothing, just true. So what we have learned from this, that we need to do two different things. My first function will be calculating my height at the current node I am present. For example, I am present on 3. I need my left and my right height. For example, I'm present on 7. I need my left and I need my right height. So every time what my height function will be doing, I'll be passing these different nodes to my height function. I'll traverse normally. I'll definitely traverse normally like we traverse in our tree depth first search. First I'll go 9, then I'll go 20, 15, 7. I'll traverse completely normally, but the thing which I'll be checking is at each point, at 20, at 15, at 7, what is my left and what is my right? And now what is the difference? What is the absolute difference? Why I'm taking absolute difference? Because suppose left is 1 and right is 2, and you subtracted left minus right, so it will be negative. So just to tackle this negative, I'll be taking absolute of them, and it will be positive 1. Now let's jump on to the code. Ignore these two lines. I'll be explaining the importance of these two lines, but ignore these two. Normal traversing, okay, and I'm collecting my height. I'm collecting my height from this function. This is my height function. If you don't know how to calculate height and depth, I'll make another video, but this video is on, this balancing subtree. So what will my left height? Suppose I'm standing on 3. Okay, I'm standing on 3, and I asked this problem. I asked this, that what is my left height? Okay, so I have a faith that this will provide me with my left height. In this, what will be my left height? My left height will be 1. So this will be equals to 1. Sorted. Now this will check for right because I have sent the root right. So what will be the height of my root? Obviously it will be 2. It will be 2. So it is 2 now. Now what I am checking, if absolute of left minus right is 1 minus 2. If absolute of 1 minus 2 is basically 1 only, is greater than 1, then return false. If this would have been true, if this would have been the condition something, give me a moment. Uh, just a second. If the condition would have been something like this, 9 and 16, okay. Now my right is equals to 3 and my left is equals to 1. 3 minus 1 will be equals to 2, which is greater than 1, which is greater than 1. I would have returned false here, but this condition is not true, so I'll not return false. What I'll do, I'll traverse to left. In this, using this, I'm traversing to left. I have used this height function for calculating, the height of each node, but this is my traversing, this is my basic traversing, and I'm collecting the value. I know this method is very layman because I at this moment I could not figure out that cool method which I use. It is something like uh, I use this root, and instead of giving so many if else condition, this generally works. Be calling this, and but for few conditions this failed, so I skipped this. So I'm collecting my data in left and right. So for this will return true, and right will also return true. So if any one of them is false, if any one of them is false, return false. For example, this left subtree, this whole left subtree, I'll draw another example. I have this 3 something something 13 here, then 9, then 15. For example, this subtree, and I have this subtree again, depth. Okay, for example, this subtree provides me with false, which means somewhere down the line, I don't know where, but somewhere down the line, this can be much of much and much depth. Somewhere down the line, the amount, the left minus right is greater than 2. For example, let's consider here only. I have this, okay, and this is my node somewhere down the line. So currently my left will be equals to 3, my right will be equals to 1. Left minus right will be equals to 2, which is greater than 1. This whole subtree is not height balanced. This whole subtree is not height balanced. So I cannot expect my overall tree to be height balanced, because in this question we are clearly provided that a binary tree in which left and right subtree of every node, if we encounter false anywhere in our tree, if we encounter false, we'll just keep returning false. So that's why I have used this, that even if you encounter false in left or if you encounter false in right, just return false. If this is not true, if everything, like if after passing whole tree, uh, if left and right are still true, then this means that uh, this is our balance tree. But I would like to show you this example because this was failing earlier. So what I did, I printed out the exact value at each node. I'll just draw this. I'll also show you what it looks like. This basically 1 2. Okay, how should I take this? Give me a moment. I'll just draw this here. While using my previous approach, like previous which I've tried, not this one. This is totally right. Another approach which I've tried. This was giving error, so we'll see why it was giving error, and I'll just write the numbers here. What numbers I'll write? I'll be writing the left and right count at each node. Okay, I'll be writing left and right count. So for example, should I change the color of this stuff? Give me a moment. Yep, I'll be writing the left count. What is left count here? 1, 2, and 3. Okay, what is right count? 1, 2, and 3. Left and right, 3, comma 3. And I'll also write the subtraction 0. Okay, I'm on this left count 1 and 2, and so left count will be 2, right count will be 1. So 2, comma 1, and subtraction is 1. Okay, yep. Now I'm on this 4. Sorry, I'm on this 4. Left count is 1 only, so this will be equals to 1. Right count is 0 because there is nothing on the right of this. For this it will be 0 comma 0. So my absolute values will be sorry, 0 comma 1 comma 0 comma 1 comma 1 comma 0 for this also. Now I'll calculate for this. What will be my absolute value? It will be 0 comma 2 because I have 2 on right, 0 on left. Now for this, 0 on left, 1 on right, again 0 and 0. Now have a look on this. Okay? Have a look clearly. एक second, I'll just delete them because you don't need to see this, but the main thing which you need to see is that how we are traversing, how we are going through. Okay, I forgot this one, I forgot this, my bad. This will be equals to 0 comma 0 again. So according to our depth first search, how we should traverse, how we should be going, we should be going in this direction first. Okay, this will be our first direction. Then we should be coming back to 2. Then again we should be going in this direction. Then again up, again on the top, and then we should be going all the way to the right. Okay, this should be our manner. And if we'll just write our left and right values of this manner, they will be equals to 3 comma 3, this value, then this value, which will be equals to 2 comma 1, then again 1 comma 0 as we traverse in depth first, then 0 comma 0, then we'll come back on this 2, we'll come back on this 2 from down. Okay, so this will be, but we have already considered this 2 comma 1, so we will not be considered this 2 comma 1 because we have already written 2 comma 1. We will not consider this again. And then we'll move on to this 5 because this is left. We have already traversed this 2, this 5 is left, so this 5 will give us 0 comma 0. After that we have already traversed our 1, we won't be going on 1, we'll be directly jumping onto the 3. So on 3 what will be? 0 comma 2. After that it will be 0 comma 1, and after that it will be 0 comma 0. So if every test case passes, this will keep on going. For example, this pass, this 0 comma 0 passes, we'll see from left. Okay, if this 0 comma 0 passes, we'll move on. If this 1 comma 0 passes, if this pass, leave it. I'll just explain you why I wrote this and the practical implementation. So practical implementation is when I'll run my code, for this. What the heck? Syntax error. Yep. You'll see something. You'll see the importance of left and right. So here we are. What is the first left? First left is 3 comma 3. What is 3 comma 3? Okay, we are standing on this. What is the second iteration? Second iteration is 2 comma 1. Where is 2 comma 1? This is 2 comma 1. So we moved in this way, as I told you earlier. What is 1 comma 0? 1 comma 0 again, following the typical depth first search. 1 comma 0 this. Then next should be 0 comma 0. What is next? 0 comma 0. Sorted. After that, all of these are traversed. Now we should be traversing this because depth first is no. So again it should be 0 comma 0. Okay, it is 0 comma 0 again. After that, this one is traversed, this is traversed, this is traversed, this is traversed, this is traversed. Which one is left? This is left. What will be the value? What will be the value? The value will be on left, it has nothing, so we have 0 on left, 0 on left, and 2 on right. But my friend, 2 minus 0 or 0 minus 2, absolute value of course, is 2, which is greater than 1, which means as this tree is not balanced, at this point. So if this is not balanced at this point, the whole tree is not balanced. So at this point I need not to move further. I'll just return false, and you'll see that this is my left, this is my last iteration. Left is 0, for this tree. Right is 2, for this tree. As soon as we encounter left minus right is greater than 1. We just returned false. We never went ahead. We never went ahead to this whole tree. Suppose you would have a long ass tree here. Suppose this whole tree would have been there. But as soon as we encountered false, we'll just return from this. We'll just return from this, and we'll keep returning false. We'll keep returning false. As soon as our left will encounter a false, it will return false again, and this will continue till we reach to the top, and finally we'll return false in the whole question. So you must be having idea of recursion and tree for understanding this question. This was definitely easy to make up in mind, but not easy to explain because this definitely needs 10 to 15 minutes more. So thank you so much.